this video, we are going to discuss about the binary frequency shift keying. On completion of this topic, students will be able to understand the concepts of Bfsk. So normally, what is FSK? FSK is frequency shift keying modulation. This is used in the digital communications and low cost application. Mainly it is used for transmitting the data at a low rate or high rate in wired as well as wireless channels. In general, we can say that M-array FSK modulation are becoming efficient modulation scheme. So several forms of this FSK modulation are popular in the spread spectrum communication. Here one of this is two carrier frequencies are used for the binary shift keying modulation. One frequency we call it as mark frequency and other we call it as frequency. So by the conversion, mark frequency indicates the higher of the two carriers which we are using here. And the generation of binary FSK signals. So normally binary frequency shift keying is a type of digital modulation which is used in sending one bit per symbol, that is 0 or 1. Hence if you are sending the bit rate and the symbol rate are same, then in a Bfsk the information is encoded in the variation of frequency of the carrier. So we can represent the 0 by the carrier frequency F1 and 1 by the carrier frequency F2. So here we have two components. One is on off level encoder, the output of which is we are having the constant amplitude is in response to the input signal 1 and 0 in response to the 0. So this binary sequence is given to the on off level encoder. From that it is given to M of t, another one is given to inverter. Both the signals are added and finally a binary Bfsk signal is produced. This binary Bfsk transmitter is shown as shown in the figure has on and off level encoder. So this output of this encoder for symbol 0 and 1 volts for symbol 0. So this detector contains two correlators. When we have the symbol of 1, then the first upper signal when you transmitting to the oscillator F1 for the frequency F1, the symbol 0, and because of the inverter the lower channel is switched on which this oscillator frequency will be having the lower frequency. Finally these two frequencies are added and the signal is transmitted. The transmitted signal is nothing but it requires the Bfsk signal, and this incoming Bfsk signal is common to both the correlators. So mainly it contains the upper and lower correlator. The main upper correlator is also having the form, it is passed to the correlator, and the lower one it is passed to the inverter. So the correlator outputs are subtracted one after one another, which produces the random vectors. So while comparing, this output I is compared to the threshold of the 0 volts, and the bandwidth is very limited. Since the physical capabilities is not susceptible noise, it is having the limited factor of bandwidth. So you can see the bandwidth rate, bit rate is very small, and the applications is it has the on voice grade lines that we can use up to 1200 bps, and it is used for the high frequency radio transmission. In the case of high frequencies, it can be used in the coaxial cable, and also it has the two-dimensional space with two messages S1 of t and S2 of t. Thank you.